Hi everyone, this is James Langridge from TinyROM, and welcome to episode 3 of my Flowcode series. In the first episode, I rushed you through a Hello World program, so in this episode, I'd like to take a little more time and to explain what I did. I would like to take you through the steps of creating a project, and also tell you why in the previous episodes I said that what I did wasn't the right way of doing things. First things first, create a new project. Open up Flowcode and then click on New Project. We'll be creating an embedded project, that's to say creating everything on an electronic board, so go ahead and click on Embedded. Next, we will need to tell Flowcode what our target is. This example can be installed on just about anything, but for this episode, I'll keep on using my stem Terra, which is an Arduino, and it is an Arduino Uno R3 using surface mount, so SMD. You can also right-click on a target to add it to your favorites. If you click on the Project Description tab, you can enter a title and a quick description of your project. For this project, I'm going to call it Blinky LED. The General Options tab is where you can change a few details, like the clock speed and the programming port. We have no need to change the clock speed since it's already set in hardware, and all Unos run at the same speed, so this time, the parameter can't be changed. When using the chip directly, you can change the speed, since you could add an oscillator, and you need to tell Flowcode what speed the clock is running. The programming port, however, must be changed, so that Flowcode knows where to send the data. We'll leave the other options at their default values. The Configure tab is used for some projects where you can set system variables like internal and external oscillators, eFuses, and other hardware points. We don't have any for the Arduino Uno, so we'll ignore this. Once everything is set up, click on OK to create a new project. If you made a mistake at some point, or if later on you decide to change some of your hardware, you can always come back later and change everything you need. When the project is created, you are presented with an empty program. All you have are begin and end, and it is up to you to fill in everything you need between the two. Your screen should look something like mine, but don't worry if there are differences. The windows can be placed however you prefer, so things might vary. On the left-hand side, you can see a list of icons. I is an input, and will get digital information from a pin. O is an output, and will set the pin either high or low. D is a delay, and will let your program idle for a set amount of time. Decision will let your program make a decision on a yes-no basis. Is this true? Yes or no? Just underneath it, we have switch. It is another decision, but one that can have multiple outcomes. For example, if you roll a 6-sided dice, the outcomes are either 1, 2, 3, 4, 5, and 6. Switch will let you create an outcome for each possibility. Just underneath, you can declare a connection point, and underneath that, tell your program to jump to a predefined connection point. Next, we have the loop, which tells your program to repeat a portion of code a certain amount of times, or forever. The macro call will call functionality to your program. We'll get into this later. Likewise for the component macro, which adds features relating to hardware, or at least most of the time. A simulation macro can add simulation events and options. Interrupts will add interrupt handlers to your program to let your design react to different situations on its own. Calculations let you do exactly that, write down calculations. C-code lets you add C-code to your project if ever what you want to do can't be done with Flowcode, but don't worry, you probably won't need this. And finally, the comment, that can add comments to your project to let you, or someone else, know what it is you are doing. And now, time to write the program. So as I said, we want to blink an LED. We want to blink the onboard LED, which is connected to port B5. So, this is something we're going to be doing forever, so let's create a loop. Click on that, drag it to the window, and you've created a loop. While 1, so this is something that will continue forever. Now, I want to turn the LED on, so this is an output, which I'm going to drag here. I'm going to double click it, and we said that port B, and we want a single bit, which is B5. We want to send the value to 1 to turn it on. Now I want to add a delay, so I'm going to drag the delay. Again, double click, and I'm going to say 500 milliseconds. I want another output, which again is going to be on port B, single bit B5, and I'm going to turn it off, 0. Again, drag down the delay. Put that down to, for example, 300 milliseconds, because why not? And that's it. We've just created a nice Hello World program. Now, to flash our program onto the board, we go up here to the Compile to Chip icon, click on that. The project must be saved before it can be compiled to C code, which is normal. So I'm going to save that. I'm going to call it, well, new blink, because that's what it is. It already exists. Do I want to replace it? Yes. Connect your Arduino. The Arduino is connected, so OK. And it's flashed. And as you can see, the LED is now happily blinking. Now, in a previous episode, I said this wasn't the right way of doing things, so let me show you why. Just at the top, we have a series of icons. Inputs, outputs, displays, sensors, data, comms, hardware, API, runtime, and creation. All of these icons will add functionality of some sort. For example, if we go into comms, we can see that we can add SPI master, SPI slave, a little bit of TCP IP, some Bluetooth, and there's even Modbus, which isn't something you see every day. Inside of data, we have some data storage in the form of a circular buffer and an EEPROM. Sensors, we have a whole range of sensors ready for you to use. And more surprisingly, in outputs, we have something that I didn't expect to see, which is an LED. Now, why would you need a driver for an LED? It's just a pin. If the pin is on, the LED is on. If the pin is off, the LED is off. Well, there are a few reasons, and let me show you why. First thing, I'm going to add this to my project. I'm going to double click it. And it arrives here into the 2D dashboard panel. If we click on it, we have a little bit of properties. So the name is LED 5mm1. I'm going to change that. I'm going to call it Blinky. The pin. It is connected to pin PB5. That's what we said earlier. The color. Well, I'm colorblind, but that looks nice. Oh, that one. Show property. No, I want to show the name. And we have, if we zoom in just a little bit here, an LED called Blinky. Okay, why? Well, something up at the top here called Run Simulation. If I click on that, and it starts blinking, exactly the way our program wanted it to. So we've managed to simulate part of our program without even having an electronic board. You can disconnect everything. So you can create simple and even complex programs and simulate them directly on a desktop. But that's not the only reason. If we go to components here, we see something called Blinky. Turn on, turn off. So we can use our component and we can add this functionality. So what do I want to do? I want to say turn on here, which is exactly the same as our output here, but this is more visible. We know that we're turning Blinky on. So I don't need this anymore. And turn off. Again, it's the same as this, so I don't need this. Now that's nice, that is a little bit more visible, but for the time being, our stem Terra has a nice little internal LED, which isn't very bright and it isn't very big. If I want to make something that does Morse code, then we're going to need an LED that is much bigger and much brighter. So to do that, I'm going to go back to Blinky, and I'm going to change the port from B5 to B0, why not, which is digital pin 8. And all I have to do is click. Now remember, using what we had previously, now if I go back here, the outputs, and I'm going to say that I want this to be port B, single bit, 5, and I have to turn it either on or off. I have to go into every single function that I've made, and I have to be sure that I've clicked every single one. If I miss one, then the program's not going to work the way I expect it to. In C, you can use defines for this. You can say define, Blinky pin, and then you can put a hardware pin. In Flowcode, you can't do this, or more precisely, you don't need to do this. All you have to do is just add an LED. So if I get rid of this, I'm going to flash this to my board. Okay, there we go, it's flashed, and now I'm going to add a little bit of hardware to the board and see what happens. Now, in order for this to work, I need to add an LED to pin PB0, which is digital pin 8. So one resistor there, the LED, and back to ground. And there you have it. We've added a component to our project that not only makes the whole program more visual, but also allows us to simulate our project, speeding up development time and helping to learn how to use Flowcode. In the next episode, we will be changing this program to make a Morse code emitter, and we'll be using macros to make our code even more readable. That's it for today. Take care of yourselves, and I hope to see you next time. Bye bye.